Good afternoon, everyone. This video is made for educational purposes, discussing that message. We are discussing machine learning model performance metrics. Um, First of all, evaluating models is crucial to ensure they perform well in real-world applications. Which simply means for real-world applications to work, we have to make sure we take accurate data on performance metrics. Accuracy, precision, recall, and various evaluation talks must be taking place. Why do we need model evaluation? Now, when we build a machine learning model, how do we know it's working efficiently? We need proper evaluation metrics. For example, in medical diagnosis, false negatives can be dangerous, while in spam detection, false positive might be actually good. So in this video, I'll walk you through the key evaluation metrics used in classification models. Positives, false positives, true negatives, false negatives, and the likes. So I'll call on my colleagues to discuss accuracy.
Yeah, I'll be discussing on accuracy. Accuracy is one of the simplest evaluation metrics. It tells the proportion of correctly classified instance out of all the 3,000. For example, if you have a model that classifies email as a spam or not spam, it predicts 90 out of 100 correctly, and the accuracy will be 90%. However, accuracy can be misleading in imbalanced data sets. If a data set has 95% negative cases and 5% positive cases, a model that always predicts negative will always have 95% accuracy, but completely useless. That is why we need other metrics. We move on to the next one, which is precision and recall. Precision and recall are two important metrics, especially when accuracy isn't enough. Precision measures how many of the predicted positive cases are actually correct. It is important when positive is positive. Now, on to the recall or sensitivity measure. It measures how many actual positive cases the model correctly identified, and this is important when missing positive is risky. Example, in cancer detection, missing a cancer case would be life-threatening.
The next one, I think I'm talking about specificity, which is also referred to as true negative rates. This measures how well the model identifies negative cases and is useful when false positives are costly, such as a medical test. It has a mathematical formula which it is true negative over true negative plus false positive. Moving to the next one, I'm talking about F1 score. This F1 score balances precision and recall, making it useful for imbalanced data sets like fraud detection and also spam filtering. It helps when both false positives and false negatives matter. It also has a mathematical formula which refers to as two times precision times recall over precision plus recall. Thank you.
So precision recall, PR curve. The PR curve shows the trade-off between precision and recall. A high precision recall curve means a model maintains good recall without sacrificing precision. It is useful when dealing with imbalanced database like diseases or fraud detection, where false negatives matter more. So another one is ROC curve, which is the receiver operating characteristics curve. The ROC curve plot the true positive rate recall against the false positive rate. It helps analyze model performance across different classification thresholds. A model with a perfect ROC curve, you have an area under curve, AUC, close to 1, meaning it performs well in all thresholds. So there's another PR versus ROC curve.
Based off of the last discussion, this section will be talking about when to use PR curve versus when to use ROC curve. Basically, you use PR curve when you are dealing with imbalanced data sets, such as positive cases. And for example, positive cases in these ROC curves are usually rare. And you should use ROC curve when both classes are very imbalanced. Note that it's important to know when you should use either of these models, as they can affect the data sets. And the conclusion of all these things is basically different type of matrices they solve for different type of purposes. That means depending on your data set, depends on the kind of metrics you use. Accuracy isn't always like they've mentioned before. Accuracy isn't always the best metric, and it is correct to choose the right matrices based off of your problems. So in this summary, machine learning models is crucial for building reliable AI solutions. Accuracy isn't always the best choice based off of imbalanced data sets. Instead of metrics precision, recall and F1 score is usually better to make decisions. Understanding these metrics ensures that you deploy the right model for the right task. Thanks for watching.